Hello friends, welcome back to my YouTube channel. Today in this video we will discuss projectile motion. This is very important topic for the entrance examinations, for A-level physics, for +2 physics. In this video at first we will make some theoretical background and then we will start to solve some numerical problem and some multiple choice questions. In the derivation of the projectile motion, we make different suppositions. The suppositions are also very important for your entrance examinations, so watch this video till last and you will be able to solve problem from projectile motion. Now let us begin with the definition of projectile motion. A projectile motion is two-dimensional motion under a constant force. It means if a ball is rolling on the ground, then that is not a projectile, because a ball is rolling on the ground means it is traveling in only one direction. Now if a basketball is thrown by a player to a basket, that can be a projectile because that is traveling in two dimensions. Now let us see another definition. A projectile is a body that moves only under the action of acceleration due to gravity when it is initially projected. It means that there should be no air resistance and body should move only under the action of gravity. That gravity provides the constant force. Now the path followed by the projectile is called trajectory, and the trajectory of projectile is parabolic. We will discuss this what is parabolic path and what is the mathematical expression in upcoming slides. So projectile means a body should move only under the action of gravity and the direction should be two-dimensional. Now let us see, there are two cases of projectile. One is horizontal projectile and another is vertical projectile. In this projectile, if a body is projected in horizontal direction, if a body is projected like this parallel to x-axis, such projectile is called horizontal projectile. But if a body is projected like this towards vertical direction, such projectile is called vertical projectile. Now let us learn this, the key point of projectile motion. In projectile motion, we split its horizontal and vertical components, which is requirement of projectile because there are two directions, horizontal direction and vertical direction. About horizontal component, when we throw a projectile from ground, its horizontal component or x component of velocity, that is ux is equal to u horizontal is equal to u cos theta, remains constant throughout the motion. See in this diagram, this u cos theta, there is u cos theta, this is called horizontal component. This remains constant throughout the motion. Whatever be the position here, here, this remains constant throughout the motion because this is towards x-axis, and we know that in projectile motion only one force acts, that is gravity, and gravity always attracts body towards its center. It means it acts towards y-axis. It acts towards for the motion of y-axis it acts, for the motion of x-axis it does not show any influence. Because of that, this velocity remains constant. If velocity remains constant, then our graph will be like this. This is for the constant velocity, a straight line. Time is changing but velocity is straight line. If velocity is constant, then acceleration must be zero, because in uniform motion or if a body is at rest, in these two cases acceleration of body becomes zero. In the case of projectile, if we consider only the horizontal component, horizontal means towards x-axis, gravity only affects y-axis. Because of that, the horizontal velocity remains constant. Because of that, horizontal acceleration remains zero. Because of that, this line will overlap towards time axis. If in time axis the acceleration is coming, means in this axis value of acceleration is zero, as shown in this graph. Now the body is gaining some distance towards x-axis. This is the distance towards x-axis. When a projectile reach here, the body will reach here towards x-axis. When it come here, and then body will reach here. This is the distance travels towards x-axis. So when time increases, the distance travel towards x-axis also increases. Because of that, this first graph represents the distance versus time. As time increases, the distance also increases. This is horizontal distance increasing. For example, if a plane is taking off from Tribhuvan International Airport and it is landing at here at Delhi. Then when body goes here like this is the displacement, this is the distance traveled towards x-axis, this is the ground distance. So ground distance is also increasing, but the velocity towards x-axis is constant and acceleration is 0 in the case of horizontal component. Now let us see vertical component. When we throw a projectile from ground, it moves towards y-axis with this velocity, it moves towards y-axis with this velocity u sine theta. It moves towards y-axis with this velocity u sine theta. Now when body goes up, then acceleration will decrease the velocity of the body, because acceleration acts vertically downward, but we are throwing our body vertically upward. Because of that its distance decreases with time. This type of curve means distance is decreasing with time. At maximum height it will stop momentarily and then it will fall to the ground. So this is distance versus time graph. The maximum velocity of body was at the point of throw. When it was thrown, its velocity continuously decreases, and at maximum height it becomes 0. And then it goes towards negative axis. In this case, the velocity is continuously decreasing. So acceleration is minus 9.8 meter per second square. That is constant. So acceleration will be like this. So the acceleration of the projectile will be acceleration of the projectile is only because of acceleration due to gravity, because x component acceleration is 0. Now let us move to theory. So that the path of projectile is parabolic. We know that we can resolve the projectile in its different component. Now let us see the horizontal component. In horizontal component, we can modify formula s is equal to ut plus half at square. It means the body is traveling towards this axis, so distance will be x. S can be replaced by x, and our velocity towards horizontal is u cos theta, and acceleration towards this axis was 0, because body motion, there is only gravity affects y-axis. Now on keeping this all value in this relation, s is equal to ut plus half at square, we will get x is equal to u cos theta into t. Because of that, t is equal to x upon u cos theta. This is because of horizontal motion. Now let us see vertical motion. If we see vertical motion, initial velocity will be u sine theta, acceleration will be minus g because it is against gravity, distance travel will be y, because in the x-axis it was x, in y-axis it will be y. On writing this all value here in this relation, we will get s is equal to u sine theta into t minus half gt square. Now we know the value of t from equation 1. If we substitute that value here in the place of t, we will get one relation. On substituting that value, we will get one relation that relates y with x and x square. Other term are a and b, they are constant. So the expression will be in the form of y is equal to ax plus bx square. That is equation of parabola. Because of that, motion of projectile is parabolic as shown in the figure, like this in dome shape. That is the motion of parabola. Because of this mathematical expression, we say that motion of projectile is parabolic. Now let us move to time of flight. See, when you take off from Nepal and before landing to Delhi, if you take off from Nepal before landing to Delhi, all other time will be small t. If your flight is for 3 hours, that complete 3 hours is capital T. If you see your watch after 2 hours and 30 minutes, that will be small t. If you see your watch after 2 minutes, that will be small t. But the time period of projectile means time taken by the projectile when it is in air, when it remains in air. Now for the time of flight, we take our vertical motion because it is moving towards vertical axis. If it is moving towards y-axis, that is it is in air. Now we know that s is equal to ut plus half at square for vertical motion will be y is equal to u sine theta into t minus half gt square. When projectile reach from this starting point to this point, when it lands, this comes to x-axis again. It starts from x-axis and it comes to x-axis again, because in Tribhuvan International Airport, it was in airport, it was while taking off, it was in the ground. Now in daily also it is in ground. In ground means towards x-axis, in x-axis. So y, value of y will be 0. Because of that, for a complete time, or for a time of flight, y will be 0 and small t will be capital T. Now on solving this, on keeping y is equal to 0 and replacing small t by capital T, we will get half gt square is equal to u sin theta into t, and our final answer will be 2u sin theta by g. Do remember this. This is important formula. Time of flight for a projectile thrown from ground is 2u sin theta by g. Now when projectile reaches just this half maximum height, then this time will be half, because it will take half time here and half time here. So time to reach maximum height is u sin theta by g. U sin theta by g. Now horizontal range. Horizontal range means the horizontal distance traveled by the projectile during its time of flight. This distance is called horizontal range, from beginning point to end point, or it is the distance between point of projection and point of landing. Now in this case we need to modify our formula towards horizontal axis. Our formula has s is equal to ut plus half at square. S will change to x. Velocity is u cos theta towards this axis. Acceleration is 0. Now small t will be replaced by capital T, because body is reaching here in capital T time. Now we know our formula for capital T. Now using the capital T from this 2u sin theta by g here, by using that 2u sin theta by g, we will get our r. In this relation, u cos theta is here, small t will be replaced by capital T, and we will substitute value of capital T, and we will get our r, that is u square sin 2 theta by g. Our t was 2u sin theta by g, and r is u square sin 2 theta by g. Now let us move to maximum height. For this maximum height, this is the maximum height is the height covered by the projectile from x-axis. Maximum height covered by the projectile from horizontal axis. For this we will use this formula, b square is equal to u square plus 2as. In this maximum height, at this maximum height, the final velocity of y component will be 0. At the maximum height, uy will be 0, because we are considering this vertical motion. In vertical motion, our u will be u sin theta. So and a will be minus g, and s will be h max. And on solving this, we will get h max is equal to u square sin square theta by 2g. U square sin square theta by 2g. Now these are the three important results of this projectile when thrown from ground. Now this is horizontal projectile. In this case, projectile is thrown parallel to x-axis. So initial velocity towards y-axis will be 0, because we are throwing projectile towards x-axis only. Initial velocity towards y-axis is 0, but as it moves down, it will gain velocity towards y-axis, and it will gain some its velocity was already towards x-axis. That will change, but it will gain y-axis velocity. Initially its velocity was 0, because it was thrown towards or parallel to x-axis or horizontal axis. It will gain certain velocity after throw towards y-axis, because it descends to this direction. It goes down, it travels distance towards y-axis also. Now let us see this path is parabolic. This path of horizontal projectile is also parabolic. Let us consider motion towards x-axis. S will be x, ux is u, a is 0. This is also projectile, so acceleration towards x-axis is 0, but initial velocity is u. Now on doing that, we will get t is equal to x by u. Again consider motion along y-axis. It is same as the first case, but this is too easy. In s will be y towards y-axis, and initial velocity is 0. Initial velocity is 0 and acceleration will be g. In this case it will be plus g, because it is falling down. And on solving this, we will get this expression. This is again another type of parabola. So motion of projectile, vertical projectile is also motion of horizontal projectile is also parabolic. Now let us see this time of descent. When projectile descends, or this is also called time of flight, but time of descent is good term here. The time taken by the projectile from this point to reach here will be, we know that s is equal to ut plus half at square. Initial velocity towards y-axis is 0, and we will get h is equal to half gt square. because this is h, this is height of projectile is known, height of that tower from which projectile thrown is already known, that will be known for us, and t will be root under twice s by g. Now horizontal range, for horizontal range we use formula s is equal to ut plus half at square, but a will be 0, and then it will be x is equal to u into t, and x will be r, and small t will be capital T. Because of that, this will come as a horizontal range for the second case of projectile. Now let us see this. In this diagram, the initial velocity of x is same in all cases because x-axis remains same, but velocity of y is decreasing, and here it is 0, and again it is going towards. If you see by only, by is decreasing, and then it is going towards negative axis. Now this is the important part in this question. In this type of information, we need to take care of 2-3 things: velocity and direction of projectile after t second. After t second, the velocity of x component remains same. The resultant velocity will be new because of by. Bx will be same. By changes because of that b changes, and our formula to calculate b is equal to root under bx square plus by square. Now in order to calculate b after given time, after t second, we need to know bx and by. Now our by will be same as bx, our bx will be same as ux, because in x-axis the velocity will remain same. If we know the initial velocity, final velocity will be same towards x-axis, but for y-axis, if uy is the initial velocity towards y-axis, our final velocity will be like this. by means final velocity of y-axis will be initial velocity of y-axis plus acceleration into time. Now resultant velocity is bx square plus by square, root under of bx square plus by square, and direction is tan theta is equal to by bx. In this way we can get the velocity after t second. Here we need to use, we will be applying this in upcoming numerical problems so that it will be clear for you. Now let us have a look on this. Till now we derived this. This is for the vertical projectile. You need to remember this. Sometimes they will ask to write the expression. You need to select out of 4 choice which one is expression for time period, which one is expression for r and all. This is for horizontal projectile, and this is the final velocity after t time, and this is angle. Now let us see this question. In this question, it is the body is here and it has traveled this distance 6 meter towards y-axis and 2 meter towards x-axis. When the body is at this point, its arrow is showing like this. Its initial velocity towards y-axis was 0 at this point. Initial velocity, because this is same like as a vertical horizontal projectile. Now by the time the body travels distance 2 meters towards y-axis, the body travels 6 meter distance towards x-axis. Now we need to find the velocity of this side, velocity of this y-axis. Let us see the solution of this question. Here projectile has 2 velocities, vertical and horizontal. When body travels 2 meter distance towards y-axis, it travels 6 meters towards x-axis. Now our initial velocity, when a bike is about to fly, initial velocity towards y-axis is 0 and acceleration is 9.8 meter per second square. Again we have used the same formula, s is equal to ut plus half at square, and we got our t. We got our t for a body to travel to distance this, but t will remain same here in this case also. Now we know our t, and we know our distance. So distance upon time will give us velocity. Distance upon time will give us velocity. This is velocity towards x-axis. So 9.4 is our option choice B is the correct answer for this question. Have a look on this question again 2-3 times, and then you'll be clear about this. If you are practicing for the first time, then there will be some problem at first. This is not that much difficult. Now let us see this question. In this question, the initial velocity towards x-axis and y-axis are given. This is for x-axis, this is for y-axis. Now we need to find the speed after 9 seconds. And this experiment is carried out on the surface of moon. Because of that, the acceleration is 1.62 meter per second square. Now we need to find the final velocity of this axis, because final velocity of x-axis will be same. X-axis velocity will not change. Now we know our initial velocity, we know our g, we have t. Now our formula is v is equal to u plus at. So we need to find v. For that our u is given. Just we are considering y-axis only. G also given, t also given, throwing upward, because of that g will be minus, and this will be final velocity towards y-axis, and this is the final velocity or initial velocity of x-axis. On keeping this relation, we will get our answer. 7.7 meter per second is the answer. If it is not that much clear for you, hit a pause button and see this. This is not that much difficult. 7.7 is in option choice B, so this is correct answer. Now let us see this. In vertical projectile, at what angle we can get maximum horizontal range? Now we need to know the formula of horizontal range. Horizontal range is u square sine 2 theta by z. Question is asking to find the angle theta for which HR becomes maximum. Horizontal range becomes maximum when sine 2 theta becomes maximum. Maximum value of sine 2 theta is 1, and 1 can be written as sine 90. Sine and sine will cancel. Theta is equal to 45 degree is the right answer for this question. Theta is equal to 45 degree. If theta is equal to 45 degree, we can get maximum horizontal range. For maximum horizontal range, sine 2 theta be maximum, and we know that sine and cos, their maximum value is 1, minimum value is minus 1. Now next question. In vertical projectile, at what angle we can achieve maximum height is equal to horizontal range? Maximum height is equal to horizontal range. For that, what is the angle through which we must project projectile? Let us see from mathematics, from our formula. This is the expression for r, this is the expression for h. Both are distance, so they can be equal at some point. So according to question, let us equate them, and u square and u square will cancel here. Sine 2 theta is equal to 2 sine theta cos theta. G and g will also cancel here. After solving this, we will get tan theta is equal to 4, and theta will be 76 degree. If we project by making 76 degree, then we will get this condition. We will get this height is equal to horizontal range. So answer for this question is 76. 76 is in option choice A. 76 is the answer for this question. Now last question. In this question, two identical ball are here, and one is just drop here and another is projected here, and question is asking which body will reach ground at first. Which in this case we need to know this formula. If the body is projected from given height, time period is twice h by g. For both the projectile, height is same, and in projectile motion we calculate this in the case of air, resistance is negligible or only gravity is acting there. Because of that, h and g are same here. H and g are same means t will be same. Both will hit the ground together. That is in option choice C. Both will reach together. So thank you very much. If you find any question, any part difficult, then I will explain in comment section. But take care of the things, revise it again and again, because if you are learning for the first time, it might be problem for you. In some cases, if you revise them, then you will get about the projectile. So this is most important topic for class 11 as well as your A-level physics as well as your entrance examinations. All the best.